online lab. It's previously scheduled to be the 4th lab, but we've changed the order a little bit this semester, so don't be confused by the number. And we're going to calculate the coefficient of restitution in this lab. So here's the activity today. We're going to drop a ball on the force plate, and we're going to calculate the coefficient of restitution when dropping with different height, or when dropping on different surface, or different kind of balls. So this lab is like the introduction of the force plate technology, one of the most common devices used in measuring human movement. And we'll use Excel to do the data analysis today. So if you've already looked at the lab manual, probably you've kind of been scared by a lot of equations here. It looks like super complicated, a lot of math here, but don't worry, we'll get through this together. So you don't need to remember it right now, but just to give you a bit of basic idea. For calculating coefficient of restitution, we're interested in the change of velocity before and after the collision, or before and after the ball hits the ground. So in equation 1 here, you can see in the red box, it's Vf over negative Vi. What does that mean? Vf means V final, or the velocity after the collision with the ground. And Vi is initial, that's the velocity right before it hits the ground. And the negative sign here just to counter the direction, because before you hit the ground and after you hit the ground, the direction is opposite. But we just care about the amplitude here, so we assume they're in the same direction, so we put a negative sign here to make it both positive values. Or when you look at here, there's another equation, equation 6, which is HB over HD. HB is a bounce height. That means how high you can reach after you hit the ground. And HD is a drop height, so how high you drop the ball and how high the ball can bounce. And if you're using the height to calculate the coefficient, we need to take a square root of the final value. So these are two important equations today. Again, V2 over V1, or Vf over Vi. V after bounce and V before bounce. And again, we only care about amplitude here. Or you can use H2 over H1. That's the height after bounce and the height, how high you drop the ball. And if you're using height, we need to take a square root of it. That's equation 6. Alright, two important equations for today. And we know that the velocity after drop shouldn't be larger than the velocity before it dropped, right? And also the height shouldn't be larger than the drop height here. So the E should always be between 0 and 1. But what does the two sides of E mean? Think about it. If E equals to 1, that means V2 equals to V1 in the amplitude, right? So there's no change in velocity after a collision. So E equals to 1 means there is no energy dissipation during the collision, and we call it a perfectly elastic collision. Now what does it mean if E equals to 0? Think about the equation again. How do we make V2 over V1 become 0? It only happens when V2 is 0, right? So what does that mean if V2 equals to 0? That means the ball is sticked on the ground after the bounce. It doesn't bounce back at all. So all the energy was lost. We call this kind of situation inelastic collision. So usually E is between 1 and 0. That means some of the energy was dissipated, but some of the energy was restored after the bounce. Yes, and so we use E to describe it, or coefficient of restitution as a topic. So let's look at the activity again after knowing the equation we need. We're going to drop the ball from certain height. And so based on the equation, we'll need 4 numbers. V1, V2 for equation 1, or H1 and H2 for equation 6. And we'll use force plate to get those numbers. But before we jump into lab details, let's take a look at force plate technology in the next video.